first questions I had was for 14.
Which quiz?
This is quiz 4.
Quiz 4?
Yeah.
Let me pull it up. Can you see my screen? Or I'm not sharing the screen. I guess I could share it, but let me get it. Let me find it for quiz 4. Okay, quiz. This is week 1. That's not it. Hold on.
Okay.
Quiz 4. Okay, so I'm going to share the screen now, and you can tell me if you can see it okay. All right, hang on. I can find you. Okay, so that's quiz 4, right? You see it?
Right. Yeah, I see it.
Okay, shoot.
So question 14.
14?
Yeah.
Okay, 14. Okay. Fire away. If you stated that the Navy equation was incorrect, how can it be corrected? That's it? Am I right with that?
Yeah.
Okay.
Yeah.
Shoot.
So basically, both sides of the equation should be squared and divided. But basically, like I get the answer, but I don't fully get the answer. So I was trying to figure out why. Like, I wanted to see if you would give maybe show it on a whiteboard, or like you.
Well, I'm interested in you seeing your reasoning. I'll give the answer out on Monday.
I'm sorry.
I say I'll give the answer out on Monday, but I'm interested in your reasoning right now. Tell me how you reason through this.
Okay. So let me pull. So the equation is.
I got it shown right there. You got it? It's right there.
Yeah. So the part where you square both sides makes sense to me, because that would cancel out the square root.
So we're taking the left-hand side and multiplying that by squaring it. So to get VE squared, right?
Yeah.
And if you square the right-hand side, the radical sign goes away.
Yeah.
That's correct. Okay, that's good. Yeah.
And then when you divide by velocity squared,
why would you do that?
That's the part I'm not getting.
Well, if you square both sides, then you'll get VE squared equals NZW over CLSQS, right?
Can you say it one more time?
If you square both sides, on the left-hand side, you'll get VE squared.
Oh, yeah.
Equals NZW over CLQS. So let me stop sharing for a second. You can see the board behind me, right?
Yeah.
Okay, so I'm going to write, let's see, I'm going to write over here, right here. Can you see that where I'm erasing?
Yeah.
Okay, so if you square both sides, help me out here because I'm not looking at it. I'm going to get VE squared equals NZW. And what's in the denominator?
I'm gonna have to, because the quiz doesn't show me when I pull up the thing, so I'm gonna pull up the notes or the slides real quick.
Okay. NZW. I think it was something QS.
Yeah, I'm grabbing it right now.
I think that's what it was, but you should double check, make sure I got it right up here.
So yeah, it's
I can't show both of them. I can either show you mine or this, but I think if you square both sides, you're going to get that. Yes.
Yeah, that's right.
Okay. So we're asking whether that's, so here's this equation I gave you in class, right?
Right.
That's the equation I gave you in class. So I'm just asking, are they the same equations?
As of now, no, not right now.
What do you mean as of now? Am I gonna change it when you're not looking?
Well, I think don't we have to do a little bit more to?
What, what more do you want to do? You want to see exactly why it's wrong?
Well, no, I just wanted to walk through the steps to figure out like how to get from one to the other.
Well, look at the numerator, right? The
Right.
numerators are the same, right? And I could take the s, so the s can go up there. That right? That can be. So I can move this like this, right? It's the same thing,
Okay.
right? So then I got the same numerator. So now the denominator's got to be the same, right?
Right.
Right? Well, the denominator has CLQ over here, and the denominator over here has what?
Q. Oh wait, no. Oh, sorry. No, that's
Huh?
no, that's not Q. That's
Well, that's what the Navy's got, right? This is the Navy. The Navy said this is right.
okay.
How can it be right? That's the same numerator, but it's got denominator has C sub L in it,
Right.
right?
Right.
So doesn't
Well, like
Q doesn't Q equal 1/2 rho say level VE squared,
yes.
right? So if you put this in there, are you going to get the same equation as this?
No.
That's all I'm asking.
Yeah. No. But so I was wondering, like, so on the quiz, it's saying that we have to square, divide by.
Let's take a look. 14.
Yeah.
14 says, I stated that Navy equation was correct. So what do you say about that answer?
I'd say that's false.
Okay. The coefficient of lift should be moved from the denominator inside the radical and replace the equivalent velocity with the equal sign. Did you do that?
No. Wait. Oh, wait. Yeah. Hold on. The
Coefficient of lift, C sub L, should be moved from the denominator inside the radical.
Oh, yeah.
Does that look
Yeah,
better?
yeah. Yeah, no, yeah. Yeah.
So
Oh,
take the coefficient of lift out of here, outside the radical, put it in here, and replace the equivalent velocity with that.
oh my gosh, I mixed up the letters. I was thinking C was.
Yeah, yeah. Are you with me now?
Yeah. No, I'm. Yeah, I agree. And then the radical, is that just the square root that they're talking about, or?
Well, the radicals is the square root of the whole thing on the right hand side.
Okay. Yeah, no,
Right.
that makes sense actually.
See, if I'm solving, what you can do with this equation over here is just solve for VE. Put this equation in here and solve for VE. So VE and then C sub L will come down here, right? And see what you get. So it's just a question of simply manipulating the equation to see. That's what I'm after. This is a simple equation, and you should be familiar with how to manipulate these terms algebraically, moving them from one side of the equation to the other, and see. And when I first saw this Navy equation, it struck me as I don't think that's right. You know?
Yeah.
So that's where the question basically came from.
Right.
So if I'm looking up here, let's see. Yeah, there's the equation. So if I'm looking over here at let me see if I get my spotlight working. This equation, if you square both sides, you go VE squared here, and then that radical will go away on the right hand side, right?
Yeah.
But isn't VE inside of Q? Isn't Q 1/2 rho C level VE squared? Right?
Yeah.
So how can VE be outside of Q?
Yeah, no, it can't.
Yeah, so I'm just kind of showing you how this is printed. This is still in print. They still, they still teach this, as far as I know, and that's why you gotta be careful
Okay.
with this stuff, right?
Yeah, that makes sense.
Yeah,
Um,
we saw Khan Academy. We saw the Khan Academy give some wrong stuff, and then we saw gravity, stupid gravity stuff for the kids that was totally wrong. In fact, it was criminally wrong almost. And what about gravity? The guy violated what Galileo proved, and they're putting this out on the web. The web is, you just can't trust it, and it's hard enough to trust sites that are really doing their best, that are authoritative. And when you start looking at the web in general, as you saw here, these are Navy notes. They're still out there. I never wrote the Navy for correcting it because I'm out of the service now. Like, and they probably have corrected. I'm guessing. Hopefully, someone caught it.
yeah,
It's wrong as hell. Yeah.
yeah. Um,
What else?
19. I
19. Okay, I'm gonna
under,
go back. I'm gonna go to share screen again. 19, huh? Okay.
I understand the correct answer is D, but I don't fully understand why those are wrong, especially C. I got a little
C.
lost just reading it, to be honest.
Yeah. Okay. Okay. So let's go. Let's do C, right?
Okay.
Let me get my so you can follow me. We'll get my stamp here. Okay. Is my stamp working? You can see that red thing?
Yeah.
Okay. So if aircraft weight is well below the maximum, in other words, you have a max takeoff weight. You can't take off more than the max weight. And that maximum weight, I didn't cover this in class, but the maximum weight is set. Actually, it's a tire limiting speed if you have to come back and land. You follow me? If you have to land at maximum weight, you could blow the tires on landing at landing speed,
Okay.
or so there's a maximum takeoff weight that's set, and if your weight is below maximum weight, the indicated airspeed for stall at 1G and the indicated airspeed for maneuvering must decrease along with the dynamic pressure so as to keep CL max unchanged and the stall angle of attack unchanged. So what I'm saying is, here's the equation. Now, hopefully the equation is familiar to you. So this is the lift pressure over the dynamic pressure. And what I'm saying here is, if the weight goes down from the maximum weight, the uh, the the speed must go down as well to keep CL max. All right. So I think the easiest way for me to explain this is to show you on my board here. Do you see the board here? This is the plot, CL max. You see that?
Yeah.
Okay, that's the plot of angle of attack versus C sub L, and there's the formula for it over here on the right-hand side, right? And if you're at maximum weight, over here, then that's going to be your 1G stall speed. Your 1G stall equivalent speed is going to be over here. And that's going to put you at CL max. It's going to put you right at the top over here at maximum weight. You follow me? So if I put max under here under W, then this equivalent is going to be the smallest stall. That's the stall speed at 1G. Okay, you with me or
Yeah.
not?
Yeah.
Okay, so if I lower the weight, and want to stay at CL max, if I lower the weight, CL is going to go decrease. So if I'm at CL max at max weight and I lower the weight, you see how I'm going to go down that curve?
Yeah.
Yeah, I'm going to go down that curve unless the velocity decreases as well. If the velocity decreases with the weight in such a way to keep this constant, then I'll stay over here. So that's all that thing is saying, is if your weight is less than the maximum weight, then your stall speed is going to decrease. You'll stall at a slower airspeed, right? And that's a safe thing, isn't it? Because if your stall speed is written for its maximum weight, then the pilot thinks, let's say it's 60 knots. I'm going to stall my airplane at 60 knots at maximum weight. Well, I'm very seldom at maximum weight. I'm usually at a weight below maximum weight normally, right? something below it. So if I'm below that, if I'm below my actual stall speed, then is going to be slightly below the maximum weight stall speed for 1G. It'll be slightly below it. But if I think it's if I think it's 60 knots instead of 55 knots, I'll be careful once it gets to 60 knots. So it's a safety thing. The safety thing says that when I compute my stall speed at maximum weight, I'm getting the safest stall speed. It's the highest stall speed that I'll get. If I'm at any other weight, then to be at CL max, I'll have a lesser airspeed. Does that make sense? That make sense?
Yeah. Thank you.
So if W goes down from W max, and to keep this number the same, then the denominator's got to go down by the same. It's got to go down. So if this goes down, VE's got to go by the square. It's got to go down by the same.
Okay.
If I cut the weight in half, right, then the velocity it's not the half. It's half square root. It'll go down by 1.4, the square root of 2, because the 1/2 is going to have to come in out of here. So so you got to play with the math a little bit with your calculator to make it work out because of the square root sign. But the key thing to remember is that I'm keeping this constant. That C sub L it's got to stay at the peak. If the weight goes down and I want to stay there, keep this constant, then the denominator's got to go down too. So you might say, well, I could lower my well, you can't lower you can't lower this because that's a constant. Sea level density is a constant. But if I'm at true airspeed over here, I could actually lower the density, and see what I'm saying? I could lower the density and do the same thing. So I could go to a higher altitude where the density is lower, and the same thing. I'll stall at a lower speed.
Okay.
Same idea.
Okay, that makes sense. Thank you.
Yeah, it gets complicated. Is there another one, or is the C kind of nail it for you? That was the hardest one, probably.
C was the most confusing one.
Okay.
But I think I could keep on just trying to play with them a little bit for A and B and try to figure it out.
Well, let's look at B. All right, let's look at B. We're looking at it. The aircraft published maneuvering speed. Again, you based on using the maximum weight. Now you might know why you use the maximum weight, right? Because then you'll get the maximum speed, and you're normally below your maximum weight, so you'd be safer. So at the maximum aircraft weight and maximum load factor, then there's the equation. If I put the maximum weight in here, I'm at the max load factor, NZ max, and I'm at the max. Well, let's see. Can you see what I'm doing? I'm playing it, but am I sharing the screen right? Probably not.
No, not right now.
Oh, yeah. Okay. Sorry about that.
All good.
Okay. Yeah, I was playing here, and I just realized, wait a second, I think I'm just talking to myself because you can't see what the hell I'm doing. Okay, so let me find that spotlight again. All right, so we're here on B. Okay, so what we're saying is if this is maximum weight and maximum G's, then I put like this could be 9 G's at a very heavy weight. The area is not going to change with the weight, but the Q, the maneuvering dynamic pressure at maximum weight, right? And that'll be some value as well. Let's see. So an aircraft published maneuvering speed is based on its maximum weight. Okay. Oh, no, that's just a statement of fact. So what's to understand there? That's just, you either agree or disagree with that statement. As normally published in flight manuals, the maneuvering speed is the maneuvering speed at maximum weight, or VA, or corner. Yeah. Do you see a problem with anything in there? I mean, it's a statement of fact. So I either said that in class or I didn't.
Yeah, I guess there wouldn't be an issue with that.
Okay, there's nothing to figure out there. It's either that's either true or false. You might have to go back and look at my notes to see what I said. All right, let's look at A. An aircraft's indicated 1G stall speed. Okay, so this N is going to be 1 in there. At maximum aircraft weight is based on the maximum gross weight in this equation. Okay, yeah, maximum weight, that gives you your minimum speed, and the maximum weight is 1/2 sea level density times stall speed at max weight. Yeah, again, that's also a statement of fact. A and B are just based statements of fact. I either said that in class or I didn't. They're actually equivalent statements. And number C is one you have to figure out that which we just did. Is that so? I don't know. I can't take you much detail with that.
Yeah, no, that makes
Without going
sense.
back to class and showing you where, yeah. But I think the thing is, Samuel, do you see why we picked the maximum weight? We picked the maximum weight for the 1G stall speed because normally you're not going to be at the maximum weight. You'll be at a lesser weight. And if you're at a lesser weight, then your stall speed will be at a lesser stall speed. So if you think your stall speed is higher, you'll avoid going below it. You see what I'm saying? So you avoid
Yeah,
going below that. You'll avoid going below the max weight stall speed that's published in the manual because you think you'll stall. You really won't stall for a few knots below that because you're not at maximum weight.
right.
Right?
Okay.
So it's a safety issue. You think it's going to stall at 60. It really is not going to stall till 55 because your weight was just less.
Okay.
It's a subtle point. It's a subtle point. I can see why you'd have questions about it. All right. What else?
Okay, thank you. I also was wondering about 20, but there's someone else in here and I don't want to make them wait forever, so I can try to
Well, let's look real quick. Yeah, let's just look at 20. Let's see what we got. Let me see what we got here. 20 or 2020. Oh, air turbulence. Okay, believe it or not, this is exactly the same thing. Flight and air turbulence occurs when the aircraft is below maximum weight.
yeah.
Okay, so if the CL max is going to stay at CL max and the weight goes below maximum weight, what has to happen? The airspeed has to decrease, right? So the maneuvering airspeed must be decreased so as to keep CL max at the same value to avoid overstressing it. Okay, so that's just what we've been saying the last 10 minutes. Okay?
So yeah, so if we decrease weight, basically the
80%. Yeah. If I decrease by 80%. So what I'm saying there is that this numerator over here, this numerator's gone to be 0.8 its old value, right? It's
Right.
0.8 what it used to be, 0.8, right? So
Right.
what will put a 0.8 down here? What will put a 0.8 down here?
Um,
The square root of 0.8, right? See that? You're gonna put the square root of 0.8 in the velocity and square it. I'm gonna get 0.8 outside. The 0.8s will cancel, and then I'll have the same C sub L.
wait, but why are you putting in the velocity if it's
Well, I could put it in the density too. I could put it in one or the other, but the question is talking about velocity. If you look at the question, the see what it says is the aircraft weight is decreased 80%. What percentage must maneuvering speed be decreased to keep CL max at the same value? Okay. So I am telling you what must you do to the speed to get a 0.8 in the denominator? You see that? I got 0.8 in the numerator. I want to keep the same CL max. So what do I have to put in the denominator? I got to put 0.8 in the denominator, right? But the speed it's speed squared. It's speed squared. So what goes inside the speed is the square root of 0.8. Then when you square it, it comes 0.8 when you take it out. You follow me? So here's here's the how come I can't get this thing? Oh, there you go. Okay. So here's the formula. We'll use this formula right here. This guy right here. We'll just say that's maneuvering speed, okay? So now all of a sudden this is that W max is 0.8. It's gone down to 0.8, okay? Right. I want to keep the same CL max so I don't overstress the airplane. Remember, if I go down at maximum G's, I go down the CL curve, I can pull more G's. Now I'll pull the wings off. So I want to keep 0.8. If this is 0.8, I got to get 0.8 down there on Q. Well, if 0.8 is going to come out of Q, it's got to go inside this square thing. So I got to have the square root of 0.8 in here. So V maneuvering speed must be the square root of 0.8. And then when you square it, it comes 0.8 outside. The 0.8 will cancel the 0.8 here, and you'll still have CL max. Does that make sense?
Okay. Yeah, I believe it does.
If you understand that, You understand more than most pilots. Okay.
Wow. Okay.
Most pilots are taught. This is what they're taught. They're taught that it's not intuitive, but when you fly in turbulence, your maneuvering speed decreases. You must decrease your speed. It's not intuitive. And pilots just accept that. They do not teach them what I just taught you.
Okay.
You see how it's in this equation. If pilots were required to learn this equation and they say, well, I'm going to decrease W, I want to keep CL max at the same, then I have to decrease the velocity.
By
Right? And
80% as well.
the velocity is inside the squared sign. So it's the square root. The square root squared is going to be the same number that ended up here to
Okay.
cancel.
So then do you just hold all other things constant as like a 1 to get the answer?
Well, it's CL max. The thing I'm holding constant is that I'm at maximum CL, right? I want the airplane at maneuvering speed is going to stall. Okay. If I lower my weight, CL will decrease. I'll be traveling down this curve.
Oh wow,
you can just, if I travel down that curve, I can pull more than the max G's. Right?
You don't even really have to look at or you don't have to actually solve for anything. I just realized if you just look at the equation, you can tell that the answer would be.
Yeah. Once you see the equation, it makes total sense. And once you understand what the equation is telling you, it makes if I decrease the numerator and I want to keep this the same, I have to decrease the denominator by the same amount.
So right? 0.8. Okay.
Yeah. So 0.8 has to come in the denominator, but it's going to be embedded in the squared. So it's got to be the square root of 0.8 in here. And when I square it, it comes 0.8 outside.
Gotcha.
And then that will cancel. See? Yeah.
Okay.
And again, what I just told you, most pilots accept without understanding why it's true. And they actually teach it. If you're going through an instructor's class for small airplanes, they'll just say, just lower your airspeed 2 or 5% if you go into severe turbulence. Don't ask why. Don't ask why. We realize it's not intuitive that you lower your airspeed when you go into turbulence.
Okay. Yeah.
But that's why, because you want the airplane to stall at a slower speed so you don't overstress the airplane at the max weight. If I stayed at that speed, I would be overstressing the airplane.
Gotcha. Okay. Thank you.
Okay, Sam. Good questions.
All right. I'll see you soon.
Okay. Take care. Okay, Robert or Vanessa, questions? You want to video yourself or unmute or whatever?
Oh yeah. So I have a question it's one of the questions in week 1 quiz 2. Because
week 1 quiz 2, okay. And go ahead and ask the question first before I go and find it.
Yeah, because it says for questions 18 and 19, well, it's like referencing them. So neglecting instrument and calibration errors, what will the airspeed indicator read in the cockpit for the flight conditions? And
oh, okay. You just told me I need to. Okay, hang on. Let's go see if I can find it. Week 1 quiz 2, yeah.
Yeah.
All right. Okay. Let me see. Where am I here? This is. Oh boy, where am I? This is not what I was looking for. Week 1.
Yeah.
Week 1 quiz 2.
Yeah. So it's toward
week 1 quiz 2 for fall. Okay, let's see. Does that look like it? Can you see it? Am I showing? Let
me go over to that tab. Yeah, I think. Actually, can you scroll to the bottom?
Yes, I'm doing. Can you see me scrolling?
Yeah.
Okay. There we go. Okay, so where we at?
That's it. Yeah, because I don't know, like I've been trying to use that one website that you told us about, the engineering toolbox, to like units, but
that should work.
I'm not getting 120 knots for both 18 and 19, but I know that that's the answer.
Okay. So I kind of like so how did you do 19?
19, yeah, so that's just plugging in the information, because there's that
into Q into equation. Okay, so let me show you. Let's go to my board. Can you see my board behind me?
Yeah.
Okay, so here's Q. this is Q right here. It's 1/2 rho true airspeed squared, yeah?
Mhm.
Or it's 1/2 sea level times equivalent airspeed squared, right? This is the pressure airspeed that,
Yeah.
that the airplane feels, okay? Okay, so if on number 20, I said you're at 20,000 feet and the sea level pressure is half,
Mhm.
right? At 20,000. So these two are equal. This one and this one below it are equal. They're the same. The pressure and 1/2 rho v true are the same. That Q is defined as either one of those. So if I put rho SL over 2 over here and set them equal, let me do that. Okay, I'll take this. So I'm going to set this equal to 1/2 rho SL VE squared. Okay, you see that?
Yeah.
But now this guy, rho SL over 2. You see that?
Yeah.
You follow me? Okay, so this cancels. That cancels. 1/2 cancels. 1/2 cancels. And you see that all I'm solving for is VE squared, right?
Yeah.
So VE squared equals, so it looks like VE squared, equals V true squared over 2.
Yeah.
And I gave you V true. Didn't I give it to you? It's 200 and something, right?
Yeah.
Yeah.
Oh,
So
it's
so you know
divided
what
by
this is, right? So you just have to divide that by 2, take the square root, and you'll have equivalent velocity.
Okay. Yeah,
You see
I
that?
think I just missed that too. Maybe that's what's throwing me off.
Maybe you might remember in class. I don't remember which class I did it, but in class I said one of the very important formulas is that Q, dynamic pressure, that's 1/2 density, wherever you're at, density times true airspeed squared, and that equals 1/2 the pressure, and the pressure density is taken to be sea level because that's how they fix the gauge. The gauge is just, and then you have VE, then you have your pressure airspeed or equivalent velocity squared. So that's the formula that you would use to solve this problem. You would just take this one and put rho SL over 2 because that's given at 20,000 feet. It's given, and then solve for VE because the rho SLs will cancel. You see that?
Yeah.
What else? Is that nail it down, or is there more?
I think that's it. Well, actually, no, because for that last quiz, there was that one question where you had to order like the different
Airspeeds, the maximum airspeeds.
Yeah,
Yeah.
but I wasn't really sure what it was referring to when it said redlining. Redlining?
Okay, the red line airspeed is the maximum airspeed that the airplane can go without structural damage. In other words, you're
Yeah.
flying so fast that you're going to be pulling pieces off the airplane. So
Okay.
normally you never go there unless you're in a death dive.
Okay.
So so let me go. You said, do you remember which quiz it was?
It was this last one. So quiz 4.
Quiz 4. Okay, I
Yeah.
think. Let me share screen one more time. Let's see if I can find quiz 4. Is this it?
Yeah.
That's it?
Yeah.
Oh, there it is. Number 12, yeah?
Yeah, that's
Are you with me? Can you see it on your screen?
Yeah, I'm seeing it.
Okay, so order the magnitudes from low to high. And there should be a slide where I did this indirectly.
Oh, okay.
I think I showed a whole batch of airspeeds that said this is why the pilot only wants to look at one of them. Do you remember that? Probably not, huh? Okay.
Not too well.
Let's see if I can find it. Here it is. Are you
That
still
one.
with me on the screen? Did the
Yeah.
slide just show up? Okay. This is what I showed in class. And what I said in class was look at all the airspeeds the pilot has to remember, and they're all equivalent airspeeds. These airspeeds don't change with density altitude or with altitude, because they're equivalent airspeeds. And then I said what the pilot does is he rotates, right? And then he goes to the best angle of climb, and the best angle of climb will get him over the trees. And then after he's over the trees, he'll go to his best rate of climb. So he'll get to altitude. It isn't the best rate. It's still higher airspeed. This is called Vx and this is called Vy. And then of course he will he'll raise the gear and flaps. Then he'll go to maneuvering airspeed. And we should know what maneuvering airspeed is, where he can pull maximum G's without pulling the wings off. And then there's never exceed airplane. And that's the airspeed you're talking about now. The never exceed airspeed is the one that just by flying at that speed, you will damage the airplane without pulling any G, just 1 G. You see what I'm saying? It's just by going that fast, stuff will start flying off the airplane that you don't want to fly off. You'll damage the airplane. So that's where I cover that in class, and so it's part of the lecture. Does that help you with solving this problem, or did you still have a?
I think that's all I had. Yeah.
Let me go back. Okay, so let's look at this number 12 that you're talking about. So let's look at these airspeeds. Okay, well now you know obviously red line is the last one, right?
Yeah.
Okay, so what's the lowest airspeed? The lowest airspeed has been when he's taking off. Yeah, right. He's taking off. So the question then is, okay, he's going to take off and he's going to climb. So you got to climb airspeed, or before he gets to climb, the question is he going to stall first? Is he going to stall first? So now well, you wouldn't want him slower than his stall speed. So actually the stall speed must be the lowest speed, right?
Yeah.
This must be the lowest speed. And then at 5,000 feet, again, if you look at the equation behind me, at 5,000 feet, if rho is in here, CL max is going to go up. So if this number goes down, if that number goes down to keep CL max the same, if that number goes down, then the weight must go down as well. So at 5,000 feet, this airplane is going to be above. Where's the airplane going to stall at 5,000 feet? If this number gets smaller, then the number next to it's got to get bigger to keep C sub L at the same value. Does that make sense? What I'm saying? Yeah. Let me put this back to how it was. So I've got it set up with that one equation, and so this is 1/2 rho be true squared. So if we're at 5,000 feet, this number has gone smaller. And if the stall speed is going to stay, if this CL is going to stay the same, then this has to go up. This gets smaller, that has to get bigger to keep this number the same. So the stall speed at 5,000 feet is going to be faster than the stall speed at ground level.
Okay. Yeah, that makes sense.
That makes sense. Yeah, that's how you would reason. That's how you would reason that through. And so you got our stall speed at 5,000. Now the question is the stall speed at 5,000 feet, what's the relation between that and rotation speed? Okay. Well, if you look at the chart here at 5,000 feet, your stall airspeed is going to go up 10% by this rule of thumb. Can you see this chart that I've got here?
Yeah.
So if this goes up 10%, how does that compare to the rotation speed? Now, I may not have covered this in class. I'm talking myself into, okay, the rotate speed is 1.2 times the stall speed normally. Okay, so you see that this is at 5,000 feet, I'm at 10% of the stall speed. The rotate speed is normally 20% of the stall speed. And I think I might not have covered that in class. That might be what's causing you trouble.
Yeah, because I don't recall like the rotate.
Yeah. I don't remember. I don't remember saying that. So I apologize for that. But anyway, so here's how it would be. It should be the stall speed, level flight, stall speed at 5,000 feet, and you can see from the equation why that's true. And that's 10% higher than stall speed. Rotation speed is 20%. It's 1.2, 20%. So this comes next after this. And then you'll be at climb airspeed, maneuvering airspeed for max Gs, which is normally 3 times the stall speed. And then you'll be at red line.
Okay.
Does it all kind of make sense now? Yeah, I didn't fully cover this question in class, so hoping people will do like you're doing, ask me to go through it in some depth.
Okay.
What else? Anything else? Good?
I think that's it for now. Yeah.
Okay.
Well, thank you.
Okay, you're welcome, Vanessa. Good luck. Thank you.
Okay.
Robert, you with me?
Yeah,
What's
yeah,
up?
I'm with you. I've been
Okay.
listening.
Sure.
I'm trying to
Get up.
absorb as much as possible.
Okay.
So I am looking at, my question is about quiz 3, passion for flight, and it's the last question, question 20.
Quiz 3. Let's see if I can find that. Okay, let me see if I can find quiz 3. Quiz 3. So that's week 2.
Week
right?
2, yeah, class 3.
Week 2, quiz 3, and week 2, quiz 3. Okay, can you see my? If I got
Yeah.
that,
And that looks right. Yep, that looks right.
okay. So which one? What
The
number?
very bottom, last question, question 20.
Okay.
Okay,
So you got
so
X15 is dropped from a B52, where the density is 1/2. That's around 20,000 feet. It will stall in the cockpit, and it should be at 200 knots.
mhm,
Okay. What's the indicated velocity in feet per second that it will stall? So you can see the first thing you're going to need is the conversion factor between feet per second and knots.
right.
Now you can either go to the toolbox on the web or
Which
use
is-
my PDF file.
Yeah, I just
Okay.
used the toolbox and converted it, and I believe it was like 338, not like 200 or 200 knots was like 338 feet per second or something like that.
Okay.
But
I believe that.
conversion sounds about.
Okay, but I'm asking for the velocity in feet per second.
Yeah, yeah.
Right,
So
okay, so you're saying that there's 1.8. I think it's 1.69 is the conversion. Let me see. I got it on my board. Yeah, actually, it's right here. Hold on a second. So I've got it right here behind me. You see it? Right
Yeah.
here. So the feet per second is 1.69 times the V in knots. So just multiply the knots by 1.69. It's 200. What'd you get? 320 or something like that?
338, I think.
Yeah, that sounds like right. So that definitely sounds right. Okay,
s-
so now you know how to do that. The other thing is okay, it'll stall at 200 knots. What indicated velocity will stall at landing on a lake bed?
So the
Okay.
density is double down there, right? Is that sea level? Is that at sea level?
Well, now think about this. Think about this indicated airspeed. What did I say in class about indicated airspeed? It's
Mm.
pressure airspeed, right?
Okay, yeah,
Pressure airspeed never changes. So whatever stall speed you get for indicated airspeed is never going to change.
got it. So it doesn't really matter that it's,
Doesn't matter where I'm at.
that's why,
It's going to stall at 200 knots, right?
right?
Got
So
that?
if it stalls
So-
at 338 feet per second, up there, it's gonna stall at 338 feet per second down there. Is that the idea?
Indicated, yeah,
An
because
indicated airspace.
that's right, because indicated airspeed, let's see if you're still sharing with me? Let me.
Yeah, I see you.
Okay.
And the.
Remember this iced tea I said? I got it shown here.
Mhm.
So what I said was indicated and calibrated. We neglect those. Those are very small errors, 1 or 2 knots. They're very small errors. So we're neglecting them. So we just say, as far as we're concerned, indicated, calibrated, equivalent, are all the same. They're pressure airspeed. It's the pressure that it feels. But there's a big conversion as shown on the left going to true.
Got it.
So if this airplane stalls at an equivalent airspeed of whatever, it's going to stall at that equivalent airspeed no matter what its altitude is.
Got it. So all that conversion, like the, let me go to the useful formulas. The, like Q equals half rho
Yeah.
VT squared. That's all for like true airspeed.
Yeah, if I was asking for the true airspeed, it would change, right?
Got it. So
Yeah,
yeah,
but
I was acting as if it was true airspeed, and that's
Yeah.
what messed me
Gotta
up.
watch me. Gotta
Yeah,
watch.
yeah. You're tricky.
I am very tricky. Yeah. Very tricky. Yeah. 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 It's
Okay.
just done to make you think, to make you slow down and
Yeah.
think about what
No,
you're
that's
doing.
good. That now it makes sense. I just thought that I was doing something radically wrong in the equation, but
No.
I'm glad that that's just what it is, because that.
Yeah. I'm glad you, and now you got it nailed down. Yeah. You
Yep.
got it nailed. Yeah. Okay.
Okay, perfect. That was really my only question. Yeah.
Okay, Robert. Well,
Thank you.
Thanks for checking in. You bet. You bet.
Yeah, have a good one.
See you next week. Have a good weekend.
Yeah, you
Yeah.
too.
Yeah. Bye-bye.